Good morning, everyone. This is one more session with respect to Linux system programming. And as all of you know that from the last two sessions, we are trying to discuss about the concept called file management. Today also we need to discuss the same things. So before starting with the today's session, if my voice is clear as well as able to see the screen properly, please type 1 in the chat box. If my voice is clear as well as able to see the screen properly, please type 1 in the chat box. Okay, thank you very much. If you able to recollect, what is the discussion happened in the last session? So just a quick question and answers regarding the last session. If you want to get the information about the file, how to communicate with the file manager? Again, if you want to get the information about the file, which function I need to use to get the information about the file? Answer is stat system call. How many arguments we need to pass to the stat function? Answer is 2 arguments. What is the first argument? Character pointer. Means path or file name. What is the second argument? Address of stat structure variable. Will you agree? What is the first argument? We need to pass the path or the name of the file. Second argument is we need to pass address of a stat structure variable. For example, stat data file ampersand of v. Struct stat v. Can you tell me where is the declaration of this stat structure? Where the declaration of this stat structure? Will you agree it is present in one of the header file? Can anybody tell me the name of the header file? sys/stat.h, correct. sys/stat.h. Now with this function call, to whom you are asking and what you are asking? With this function call, to whom you are asking and what you are asking? You are asking to file manager that I want the information about this file. Please fill this structure. Will you agree? I want the information about the file. Please fill this structure. So who will fill this structure? Can I say file manager? Will you agree this is a system call? Will you agree that is a system call? Upon failure, what it will return? Upon failure, what it will return? Upon failure, what this function returns? Upon failure, what this function returns? Answer is -1. Do you know? Most of the system calls upon failure returns a -1. Apart from returning the -1, will you agree this system call will set error number also? So that if you want, we can print the proper error message. Apart from what you called, apart from returning the -1, it will set an error number also. Please reply it as or no. Okay. Now, in this structure, can you tell me, yesterday what are the members we printed? In this structure, can you tell me yesterday what are the members we printed? We printed file size. We printed inode number. We printed permissions. We printed type of file. Which type of file? For finding the type of the file, we taken the help of some macros. For finding the type of the file, we taken the help of macros. Will you agree? These two members are present in one of the only in one member, st_mode. These two informations are present in one member of the stat structure, that is st_mode. The type of discussion happened in the last lecture. Apart from that, yesterday we are trying to understand one more important concept, that is called link file. Yesterday, one more important concept we are trying to understand, that is a link file. We can establish two types of links. We can establish two types of links in between the files. One is a hard link and another one is a soft link. Now tell me, ln abc def ln -s one two. Now in a first case, abc and def, here the hard link is there. Will you agree? In this case, link count gets increased. In this case, link count gets increased. In this case, in hard disk, is there any separate file is created, or two names pointing to same file? In this case, is a def is a separate file is created, or two files are referring to the same file? Two names are referring to the same file. Answer is two names are referring to the same file. In this case, inode numbers are same. In the first case, inode numbers are same. Just two entries in a inode table. Just two entries in a inode table. And if you delete this ABC, will you agree you can retrieve the data from DEF or vice versa? In this case, what happens is there is a separate file is created called TWO, which is a special type of file that is called link file. In the second case, there is a special type of file is created that is a soft link or symbolic link file. This is like a pointer pointing to this ONE. This is a pointer pointing to ONE. The size of this TWO is this ONE 1, 2, 3. In this case, if original file is deleted, the link becomes a, in this case, if the original file is deleted, the link becomes a dangling link. If original file is deleted, the link becomes a dangling link. In this, both inode numbers are different. In this, both inode numbers are different. In this, both file sizes are different. In this, number of link count is not increased. So that type of discussion happened in the last session. So today we need to discuss some time related issues. In the stat structure, there are three time related members are there. Can anybody know that? In the stat structure, there are three time related members are there. Can anybody tell me what are the time related members are there in the stat structure? st underscore a time, st underscore m time, st underscore c time. All of you copy these three lines and commented portion also. All of you copy this three members as well as the commented portion also. st underscore a time, st underscore m time, st underscore c time. Again, st underscore a time, st underscore m time, st underscore c time. A time means last file access, m time means last modification time, c time means last status change time. One interesting fact about Linux I need to tell you, Linux file manager will not maintain file creation time. Try to understand. One interesting point about the Linux file management is Linux file manager will not maintain file creation time. If you're getting this point, type T in the chat box. Linux file manager will not maintain file creation time. It will maintain st underscore a time, access time, m time, modification time, c time, status change time. So what is the difference between them? A time, m time, c time? We need to discuss in a today's session. Before that, some time related issues we need to discuss it. Some time related functions we need to discuss it before this discussion. Again, before understanding these three parameters, before understanding these three members of the stat structure, we need to talk some time related issues, time related function, that is man 3, is it 3 or 2, let's see, time function. There is one function, just a minute, man 2 time, time function. Note it down. Which header file we need to include? We need to include time.h and note it down the prototype of this function. Note it down the prototype of this function. Note it down the prototype of this function. Time function. Observe. What is the time function returns? Time function returns the time as the number of seconds since the epoch time. Note it down this entire line. Time function returns the number of seconds since the epoch, epoch time. Time function returns number of seconds since the epoch time. What is that epoch time? This is one of the Linux standard time. From 1970 January 1st, how many seconds are completed till now? It will return that time. That's number of seconds it will return it. Again, time function returns the time as number of seconds since 1970 January 1st. Means from 1970 January 1st till now how many seconds are completed? It will return that number of seconds. Do you know time is measured in different ways? UTC. Have you heard this UTC? GMT. Have you heard UTC and GMT? Time is what you call in a different things they will measure it. GMT means Greenwich mean time zones, correct? So it will return a number 1970 January 1st. From 1970 January 1st till now, how much of time is done? It will return it. So what is a header file? We need to include time.h. Epoch time is one of the standard time of Linux system. EPOCH is one of the Linux standard time. Normally they will say in 1970 this is a reference point. We can say in a simple way, if I say that is a reference point. Is it clear? So now let's move to display this. First, what I'm trying to do, I'm trying to include that header file. What is the name of the header file? Hash include time.h. Is it? Time.h. Now I will show you one program. VI 2309_1.c header.h void main time_t t is equals to time of 0 printf percentile LLU/n comma t and sleep of 1 second system clear. You can put it in a while one. Can you tell me what is a system clear will do? Can you tell me what is a line number 11 will do? What is a line number 11 will do? Will you agree? Line number 11 will clear the screen. Line number 11 will clear the screen. Now observe what I'm trying to do here is I'm getting the time, I'm displaying the time, I'm making my process to sleep of 1 second, I'm clearing the screen. Again the same process I'm doing continuously. Again the same process I'm doing continuously. First I'm getting the time, second I'm printing the time. The time is displayed in a seconds number. It will display one number here. The time is displayed here in the form of number. And I'm making my process to sleep of 1 second. After that I'm clearing the screen. After that I'm clearing the screen. Let me compile the code. Let me compile the code. And it is showing some LLU. You need to use LU it seems instead of LLU. I'm using LU. The time is increasing. Is it increasing? 54, 55, 56, 57. But unfortunately, it is not displayed properly, right? It is displaying one number. It is displaying one number, right? It is displaying one number, right? I want to display, if I want to display not a number, you want to display proper time format, what I need to do is printf %s slash n. There is a function called ctime ampersand of t. Now observe, is it displaying the time properly? Is it displaying the time properly? Thursday, September 23, 7:52, 06, 07, 08, 09, and 2021. Now observe what I'm trying to do here is observe this while loop. Here, what I'm doing, I'm getting the time. The time is, you will get the time in the form of one number. Will you agree? In line number 8, we are getting the time, that the time is in the form of one number. In line number 10, what I'm doing? In line number 10, what I'm doing? In line number 10, what I'm doing? In line number 10, we are, in line number 10, we are calling the ctime function and we are passing the address of this variable. Can you guess what is the ctime function will do? It will return one string. That number internally it is converted into one string, proper standard string format. It will return the address. Don't worry why we are passing here 0. We'll discuss that. Is it clear? And after that we are making a sleep and we are system clear. Now one thing I need to tell you, time function can be called in a 3 different ways. Note it down. Time function can be called in 3 different ways. Time function can be called in 3 different ways. Observe, the first method is time underscore t is equals to time of 0. This is the first method which I used it. Second method is time underscore t time of t. Second method is time underscore t time of t. Third method is time underscore t comma t1 t is equals to time ampersand of t1. Think here we need to pass ampersand. Just give me 1 minute of time. I'll cross check it. We need to pass address or what? We need to pass address or what for this time function? Yes, we need to pass address. So observe, time function can be called in a 3 different ways. All of you copy these 3 ways. Time function can be called in a 3 different ways. All of you copy these 3 ways. All of you copy these 3 ways. So the first way is this one, where whatever the time function is returning, we are catching here. Will you agree? In the first method, whatever the time function is returning, we are catching. So now the time will be available here. Now the time will be available here. Here you are passing 0. Means you are not interested to collect the time here. Here you are passing the time 0. Here 0 means not interested to collect the time here. One thing I need to tell you, time function returns the time as well as the stores the time. Again, time function will return the time as well as the store the time into that location at a time. Again, time function will return the time as well as it will store the time. Now tell me, here purely I am return value I am catching. I'm not interested to store the time. Just I'm catching here. Now here, I'm not catching the return value. I'm informing to the time function to store the time into this location. Now here, can you tell me here I'm doing both? Will you agree? I'm doing both in the last case. In the last case, I'm doing both. What is the both? I'm getting the time in this t as well as I'm getting the time in this t1 also. I'm getting the time in the t. I'm getting the time in the t1 also. Be it 8e2, getting the point. Time function can be called in a 3 different ways. Time function returns the time in the form of return, as well as time function will store into the location if you pass it. All of you copied these 3 ways. Type 3 in the chat box. All of you copy these 3 ways. Type 3 in the chat box. Okay. Now tell me, in these 3 methods, in which method I am calling in line number 8? In these 3 methods, in which method I am calling in line number 8? First method. We can experiment second method also. We can experiment second method also. What is the second method? Time ampersand of t. Time ampersand of t. See, here also we are getting the time. Now tell me, in this case, am I catching the return value of the time, or am I passing one variable address and informing to the time function to store there? Now can you tell me, in this case, am I catching the return value of the time, or am I informing to the time function to store the time into that address? 1 or 2? Observe, in this case, line number 8, am I catching the return value of the time, or am I informing to the time function to store the time into that address? Can I say I'm informing to the time function to store the time into that address? In both cases, output is same. Now observe, let's experiment third case. One of the student is asking, sir, at start, what is the t variable holds? You need to tell me what is the storage type of t? What is the storage type of t? Auto. If it is an auto, can you tell me what it holds? Garbage. Very simple. Got the point? Garbage. Very simple. Now observe. See? All of you are observing. in this case, I'm getting the time in a two variables, one in a t and another one in a t1 also. In this case, I'm getting the time in two variables, in t as well as in a t1. Now here I'm informing to the time function I want the time in this t as well as in this t1. Now one thing I need to ask you, if any function required one argument, if you don't pass that argument, what happens? One thing I need to ask you, if any function required any argument, if you don't pass that argument, then what happens? Can I say it is an error? Too few arguments. Will you agree? That is a too few arguments error. If any function returning something, is it necessary to catch it? If any function is returning something, is it necessary to catch it? Now, can you tell me here, can I call this function simply t is equals to time without passing anything? Without passing anything, can I pass it, call it? No, it is an error. Now here you are passing 0, means you are passing a null pointer. You are informing to the function that I don't want the time in any location, just return the time. I hope all of you are getting the point. I hope all of you are getting the point. Will you agree with this statement? So I hope the time function, it will return the time in the form of a return type, as well as it will store the time if you pass a proper address. Time function will return the time as well as it will store the time if you pass a proper address. It will return the time, it will store the time if you pass the proper address. And this time function will give in the form of one number. That is the reason we are using which function to display the proper time format. The time function will return the number. That is the reason we are using one function to display proper time. Can I say that is the C time function? We are using C time function to display the proper time. If this is clear, type C so that we will move to the next discussion. If this is clear, type C so that we'll move to the next discussion. The next discussion is in this case, this T is also holding the time, this T1 is also holding the time. See, I'm printing. Here we are not setting the time. B8 F1, try to understand. This function is not for setting the time. This function just give us the time. Again, try to understand. This function is not for setting any time. This function will give us the time. It will give the time in a two ways, one in the return type, one in this location it will store it. Is it clear? Okay. We are not setting the time here, we are getting the time. Okay. Next, as I told you, in a stat structure, this program is available. This program is available. One of the student is asking, is there any function to change the time? Maybe. To change the format of the time display. If you want to change the format of the time display, so what you can do is man C time. Now here different functions will be there. See, different functions will be there. You can use. GMT time, GM time, local time. I'm using the C time, right? So you can experiment if you want on this. If you want to display in a different formats. I don't know example program is there or not. Lengthy process. You can go through these functions, you may get it. Okay. Next, our discussion is, as I told you, these three members of the stat structure. These three members of the stat structure: time of last file access, time of last modification, time of last status change. A time, st underscore A time, M time, and C time. st underscore A time, st underscore M time, st underscore C time. st underscore A time, access time, st underscore M time, modification time, st underscore C time, status change time. I'll tell you, if we are opening the file only for reading purpose, if we open file only for reading, then A time is changed. If we are open a file only for reading purpose, A time is changed. M time. If we open a file for read and writing purpose, then M time is changed. Again, if we open a file for reading as well as, yeah, here the concept of make utility comes. We'll discuss that also. If you open a file for reading and writing purpose, then M time is changed. C time, if any changes are done in inode table, then C time is changed. Again, if any changes are done in inode table, then the C time is changed. As I told you, once again I'll tell you, our Linux file manager will not maintain file creation time. It will maintain last modification time. It will maintain last status change time. It will maintain if any inode entries are changed, so then it will maintain that time. So what I will do, let's experiment. I don't know if it is practically I can show it here or not. Can you tell me yesterday's program 23092.c? Just a minute. CP now, will you agree? I'm getting the information about the file using the stat function into this v variable. Will you agree? I'm getting the information about the file using that v variable. I'm getting the information about the file using that v variable. Now I need to print those times here. I need to print those times here. I need to print those times here. What is the times? Printf percentile lu /n st underscore a time v dot st underscore a time v dot st underscore m time st underscore m time. Just give me 1 minute of time. And st underscore c time. In which line I'm getting the information about the file? Can you tell me in which line I'm getting the information about the file? In which line I'm getting the information about the file? In which line I'm getting the information about the file? Don't be hurried to copy. This program is already available in our material. I'll show you. Will you agree? In line number 11, I'm getting the information about the file. And in line number 16, 17, 18, what I'm doing there? In line number 16, 17, 18, what we are doing there? Will you agree? Will you agree? We are trying to print. Will you agree? We are trying to display A time, M time, and C time. Now, I don't know practically in this Ubuntu it is possible or not. Let me experiment it. Now, I removed the data file, cat data, cat greater than data, control D, /a data out data. Now, A time is little bit early, 19. M time and C time both are same. Again, access time is showing as a 19. Modification time and status change time is showing as a 21. Now you tell me, if I write cat data, now /a data out data, that's what it is not showing in this my Ubuntu system. But when you write cat data and when you display the time, this should be greater than these two. Again, this should be greater than these two. All of you are getting the point? In this subsystem, I cannot show you that. Getting the point what I'm saying? So you can experiment in your normal thing. Now observe, in this program, in this material, where is that information? I will show you. This is the program we discussed just now, how to get the time. Listen, this is the program just now I discussed it. And this is the C time function I discussed it. Now observe, this is the program, you can copy and paste it. A time, M time, and C time. So you can experiment it. Theoretically, what is the concept is? When you are trying to open a file for reading purpose, when you are trying to open a file for reading purpose, A time is changed. When you're trying to open a file for writing purpose, M time is changed. Now tell me, here in this example, what they are doing? They are changing the file permissions, right? They're changing the inode table, right? So then which time is changed here? In this example, once the time is displayed, they're changing the file permissions. Can I say C time is changed? In this, they used cat ABC, accessing the file. Then A time is changed. A time is changed, reading. Appending, I hope you know, double greater than, appending. Then modification time and status change time, because why status change time is changed here? Because file size is increased. Inode table gets affected. File size is changed. So inode table gets affected. Getting the point? Just it's enough theoretically if you have the concept for interview point of view. So there are three time related informations are present in a stat structure. There are three time related informations are present in a stat structure. That is A time, M time, and C time. Now, when Siddiq sir is discussing about the make utility, sir might have used the concept called last modification time. What the make utility will do, make utility will observe .c timestamp and .o timestamp, and it will decide to recompile it or not. Again, this concept is used in the implementation of make utility. So what the make utility will do is last modification time of .c and last modification time of .o, it will check and it will decide it should recompile the code or not. Now tell me, last modification time of the .c is 8:15 and last modification time of .o is 8:17. Is the program is recompiled or not? Is the program is going to be recompiled or not? Again, last modification time of .c is 8:15. Last modification time of .o is 8:17. Is the program is recompiled or not? Answer is no, it is not going to be recompiled. But if it is a reverse, if it is a 8:17, if it is a 8:15, so then latest modification is done in a .c, so it will recompile the code. So this is the concept. Internally, the make utility uses to decide it should recompile the source code or it will decide to recompile the source code or not. Is that point is clear? You can go through this document after the class. Is it clear? Make utility will work with this phenomena, with this concept of last modification time. Make utility internally will get the .c last modification time and .c modification time and .o modification time. Which one is latest modified? According to that, it will make the decision. Which one is latest modified? According to that, it will make the decision. Is it clear? This is about the time related things. This is about the time related things. Whatever I discussed, that is available in this chapter. Next discussion is we need to talk about a directory file. Next discussion is we need to talk about a directory file. Can you tell me how many types of files our Linux categorizes? Can you tell me how many types of files our Linux categorizes? Will you agree? Our Linux categorizes 7 types of files. In that, one of the file is directory file. In that, one of the file is directory file. So now we are going to discuss how to open a directory file, how to read the content of directory file. Directory is nothing but like an index. See, a directory file is a special file. All of you see here, a directory file is a file with a special organization, which is essentially, it is a table consists of file names and inode numbers. Again, directory file is like a file which contains file names and inode numbers. Now, I hope all of you know that in any book, the starting page index will be there. In any book, the starting page index will be there. In an index, chapter name and the page number, chapter name, page number, chapter name, page number, like this it will be there. Will you agree? Chapter name and page number. Similarly, directory is also one type of file in a Linux where the directory file holds the file name and their inode number. Again, directory is a one file which holds the file names and the inode numbers. It will hold file names and inode numbers. So now if you want to open a directory, if you want to open a directory, there is a function called library function called opendir. If you want to open a directory, you need to use a function called opendir. Note it down, the opendir prototype. Note it down, the opendir function prototype. What is the fopen returns? What is the fopen function returns in a C language? File pointer. Capital, will you agree? Capital FILE. Capital FILE, file pointer. Similarly, opendir returns directory pointer. Again, I hope all of you might have remembered in a C language, opendir returns a directory pointer. Opendir returns a directory pointer. Like fopen returns a file pointer. What is the capital FILE? Can you tell me what is that capital FILE? Will you agree? Capital FILE is not a macro. It is a type def. It is a structure. It is a structure, right? Here also, it is a structure. Upon success, it will return. Can you tell me? Upon success, it will return the directory pointer. Upon failure, it will return a 0. Again, Upon success, it will return a directory pointer. Upon success, it will return a directory pointer. Upon failure, it will return a 0. This is just opening purpose. Once we open a directory file, what is the next step we need to do? Once we open a directory file, what is the next step? We need to read. Note it down. Read dir. Once we open a directory file, the next step is we need to read. Next step is we need to read. For that purpose, read dir is a function. What you need to pass to the read dir? What you need to pass to the read dir? Can I say open dir return type? I don't know you remembered or not. When we are dealing with the files in fgetc, fputc, fgets, fputs, fprintf, fscanf, in all these functions, one common member is file pointer. Okay, I don't know you remembered or not. When we are dealing with the files, in every file-based operations in a C language, one common member will be there. That is a file pointer. That is a return type of fopen. Here also the same thing. If you want to read the directory, you need to use read dir. It will, you need to pass the directory pointer. From where you will get this pointer? Can you tell me from where you will get this pointer? Can I say open dir return type? Now what it will return? Can you tell me what it will return? Value or address? Can you tell me what it will return? Will it return the value or address? Address. Which address? Structure address. Now very simple. If I am passing an address to you, you need to catch with. If I am passing one address to you, you need to catch with pointer. Similarly, when you are returning the address to me, I should catch with. When you are returning the address to me, I should catch with a pointer. I will show you with a program, it will be more clear and very easy. In this structure, you may get a doubt, sir, what are the members are there? In this structure, there are so many members are there, but I'm going to focus one of the member, that is d underscore name. In this structure, there are so many members are there, but I'm going to focus on one of the member, that is d underscore name. So what I'm going to do now, I'm going to implement my own ls command. I'm going to implement my own ls command. First you tell me what is the update I need to do in a header file. What is the new header file I need to include in a header.h? dirent.h. So I'm going to include that header file here. Hash include dirent.h. Next, today's 3.c. Observe, hash include header.h void main. So dir star dp. Can I say DP is a pointer variable of dir type? Like in a file operations, in a file programs, file star fp, like this we declared it. In a C language, in a file operations, we declared like this capital FILE star fp. Yes or no? So here also, here this is a directory pointer. DP is equals to open dir dot. Dot means, I hope you know what is the meaning of dot. Present working directory. Do you agree? Dot means present working directory. If dp double equals to 0, can I say something went wrong? P error, open dir, no need to further proceed it. If dp double equals to 0, something went wrong, so just open dir, failed, return it. Otherwise, struct dir ent star p. Okay, can you tell me p is a pointer variable of which type? Can you tell me p is a pointer variable? P is a pointer variable of which type? Struct dir ent. Now observe, while p is equals to read dir. Now can you logically think and tell me what is the failure when the while my program comes out of the while? Can you logically tell me when my program will come out of the while? Can I say when the p holds 0, means upon failure read dir returns 0. So then p holds the null pointer. Can I say it will come out of the loop? In this, I'm going to use printf percentile s slash n p arrow d underscore name. Can you tell me why I used arrow operator? Why not dot operator? Can you tell me why I used arrow operator? Why not dot operator? Answer is very simple. P is a pointer. In that structure, dir ent structure, in that dir ent structure, I'm printing only this member. In the dir ent structure, I'm printing only one member that is called, I'm printing only one member that is called d underscore name, file name. So in this program, what I'm trying to do is, I'm trying to open a present working directory. I'm trying to open a present working directory. I'm trying to read the entire names in the directory. I'm trying to print it. I hope all of you might have remembered, you should not increment this, decrement this file pointer. Similarly, you should not increment or decrement this directory pointer also. I hope you might have remembered in a file concept, you should not increment or decrement the file pointer. Similarly, in this case also, you should not increment or decrement the directory pointer. So in this program, I can remove this open and close brackets. In this program, will you agree? Simply I open the direct present working directory. In that, I'm trying to print out, I'm trying to list the names of the files. I'm trying to list the names of the files. Let's see. Dot slash a dot out. And it is displaying the hidden files also. I hope you may know that. In a Linux, if the letter starts with a dot, first letter starts with a dot, it is a hidden file. It is displaying that file also. But if you don't want to display that file, very simple, put one if condition here. If PRO D underscore name of 0 not equals to single code dot, then only you print it. Just I written one if condition. All of you are getting the point? Now here I'm able to print, I'm able to list the files which are present in the present working directory. Yes, we can say this is like a ls command only. This is like a ls command only. Now my question is, instead of fixing the dot compile time, can I take the input at load time? Instead of fixing the compile time, can I take the input at load time? If you want, you can experiment that. So if you see this program, in this program, they are opening the file. They are opening the present working directory. Just now I did that. They are reading the read dir and they are printing it. Upon failure, read dir returns 0. When it returns 0, my program, I am coming out my program, that while loop. Is it clear this? Type C in the chat box. Here in this demo program, we are opening the present working directory and we are reading the list of files and printing on the screen. This is the basic ls command. Now in this is the program for implementation of ls-lais command. This program is already there. Total full-fledged ls command program is there. All of you are getting the point? This is the program for ls-lais or something. If you are interested, you can go through this. We implemented ls, but we didn't implemented ls-l, ls-li, ls-ls. If you want, you can go through this program, and if any doubt in this program, you can ask it later. Is it clear? Is it clear? So this is about directory file. This is about directory file. This is about a directory file. Any doubt in this, please? Just very simple. You need to open a file. You need to open a directory using opendir. You need to open a directory using opendir. After that, you need to go for reading and writing operation. What you call read dir. And if you are more interested, ls-l implementation, the program is there in this your whatever the data we passed it, you can check it out. So next discussion is file handling using the system calls. In a tomorrow session, we need to talk about this open system call, read system call, write system call, close system call. We need to discuss it. Will you agree? We discussed file handling using the C language. fopen, fgetc, fputc, like this. In tomorrow's session, we are going to talk about file handling using S7 is asking, sir, here whole directory is accessed and whenever the file form directly can be modified using the write and read. Yes, we can open a file and we can do the reading and writing operation if you want. BE9 S7. Just now, just how to open a file, just to how to open a directory and how to read the names of the file in the directory, we discussed it. If you want that file name, when you got it, you can open that file and you can do the reading and writing operation. Once you got the name of the file, you can get the information about the file using the stat. If you want to open the file, you can open using the open system call or fopen, your wish. Is it clear? You can do the reading and writing operations also. Okay, then tomorrow we'll discuss many more things. I'm going to wind up today's session. Today, any campuses are scheduled? Today, any campuses are scheduled? Today, any campuses are scheduled? BE9, I think very soon they'll make you eligible. BE9, very soon they'll make you eligible. And for reassessment, we are looking, some other batch assessment is going on. Please be ready. And if you are in a Bangalore, just visit our branch so that directly we'll schedule it. If online, you need to wait. If you are in a Bangalore, directly visit our branch, we'll schedule it. Okay, thank you very much.